Okay, so we're going to talk about how to calculate the standard deviation of a sample. And the idea behind the standard deviation of a sample is that you're trying to figure out how spread out the data is. Okay, so finding the mean is going to tell you, roughly like what maybe the average or the typical person is. But the standard deviation is going to let you know, okay, so is everybody really close to the mean or is everybody really far from the mean? So let's look at this problem here and work through it together. The administrators at Metro want to know the average number of hours of sleep that Metro students are getting, as well as the standard deviation for this data set. A random sample of the high school population was taken, and the following results were obtained. So we've got 7 data points here, so 6, 7, 7, 7.5, 7.5, 10, and 11. The mean here, I mean, most of you guys have covered this before, but all you're going to do is find the average. So you're going to add everything up and divide by 8. And sorry, bear with me here. I was sick yesterday, and I'm still getting my voice back. So, okay, here's what we're going to do. Here's the idea behind standard deviation. You want to take each one of your points, okay? So you see right here is the x sub I column. All we're going to do is write each of our points in there, each of our data points. So 6, 7, 7, 7.5, 7.5, and forgive me, I'm writing with my finger here because I forgot my stylus at home. 10, 11. Okay, so those are our data points. The idea, if you really want to know how spread out a data set is, what you're going to do is you're going to figure out how far each data point is from the mean. Now, if you just added these up, you would get something probably really close to 0, no matter what your data set was, as long as it was symmetrical and you had about an equal number to the left and to the right of your mean. But what we're going to do here, and what's brilliant about this, is that we're going to figure out how far each data point is from the mean, okay? And then we're actually going to square that result and add those up. So when you square it, what happens is your negative distances become positive numbers. And what we're going to do is we're going to add up all of those, and we're going to divide by, well, it depends on whether or not you're dealing with a sample or a population. But we're going to divide by the total number, or sometimes we divide by the total number minus 1. So 1 less than the total number. But the idea is that what we're going to do is we're going to divide by that, and then when we take the square root of that, it will basically kind of undo the squaring that we did earlier, and it'll give us a number that'll let us know roughly how spread out our data set is. And the higher the standard deviation, that means that your data set is more spread out. Let's go ahead and do the calculations here. So, by the way, so let's talk about notation for a sec. X bar, so this is called X bar right here. That's actually, all that is the mean of our sample. So 8 is our X bar, okay? So all we're going to do here, I mean, this is actually like pretty simple, honestly, is we're going to do 6 minus the mean, okay? So 6 was our data point, and X bar was our mean, okay? So 6 minus 8, that is negative 2. And then we're just going to do that for each of our points here. So 7 minus 8 is negative 1. 7 minus 8 is negative 1. 7.5 minus 8 is negative 0.5. I'm running out of room here. 7.5 minus 8, again, is going to be negative 0.5. 10 minus 8 is 2. And 11 minus 8 is 3. Okay. Now, all we're going to do is we're going to take these results. So negative 2, negative 1, negative 1, negative 0.5, negative 0.5, negative 2, and, or sorry. Oh, that should say equals there. Sorry about that. That should say equals, not minus. We're going to take each of these numbers here, and we're just going to square them. Okay, so -2 squared. Be really careful when you punch this into your calculator. If you do punch this into your calculator and you want to know what -2 squared is, you really have to make sure you put parentheses -2 squared. Okay, because the idea is, what is -2 times -2? Okay, so you should get a positive number when you do that. Okay, so this will be 4. -1 times -1 is going to be 1. -1 times -1 is going to be 1. Negative 0.5 or -1/2. If we square that, that'll be 0.25. This will also be 0.25. 2 squared, that'll be 4. And 3 squared, that'll be 9. Okay, so now we've we've figured out the square of all of those. And now what we're going to do is we get to this really ugly notation thingy. Okay, so this thing right here, this little symbol right here, that is the Greek letter for sigma. It is their version of capital S. I don't know why it looks like an E, but it just does. So the sigma thing is just the Greek's version of capital S. And sigma means add up everything. That's generally what sigma means. Okay, so make sure you put a note of that on your paper while you're taking notes here. So sigma means add up everything. And what are we adding is the question. Well, we're adding all of the x sub i's, which were just our data points over here, minus the mean, and we're squaring them. So the xi minus x bar squared is, look, it's right here. It's all of these numbers right here. So all we're going to do is take these and add them up, and we're just going to put that result right here. This little thing, so I equals 1 to n, just means that you're going to start with when I is 1, so x sub 1 was just our first data point right here. X sub 2 is this data point, x sub 3. And n is just what we use when we have a ton of data points and we don't want to write every single one of them out. We just say, okay, so just go to the nth one, which in our case, there were only 7. I mean, there weren't a whole lot, but what if there were like 400? You would write I equals 1 to 400 here. So you'd put 400 for n, and then what you'd do is you'd take 1, 2, 3, and you would go all the way down to the 400th, and then you'd add them all up. So let's go ahead and add these up here. I'm going to punch these into a calculator. So 4 plus 1 plus 1 plus 0.25 plus 0.25 plus 4 plus 9. I got 19.5. Okay. So we'll go ahead and put that in there. So that's 19.5. And now we need to divide. So we've added up all the numbers. We got 19.5. Now we're almost to standard deviation. We're 2 steps away. What we're going to do now is we're going to take this number here, the 19.5 that we got. That was what happened when we took every number, subtracted the mean from it, we squared that result, and then we added them all up. Now we're going to divide by n minus 1. Now, the reason that we're dividing by n minus 1 instead of n is that we have a sample here, and if we had had a whole population, then we would just divide by n. It's kind of like taking the average, but since we only did a sample, we're going to divide by n minus 1. And by the way, remember, n was just the number of data points we had. So this, we had 7 data points. So we're just going to take 19.5 divided by, so we had 7 data points. So really, we're just going to do 19.5 divided by 6. Okay, so 19.5 divided by 6. I get 3.25. And I ran out of room here, but whatever. Okay, so 3.25 is called our variance. Okay, so that's our variance. And the standard deviation is just the square root of that number. So all we have to do here is take the square root of 3.25. And that will give us our standard deviation. And that is 1.8. I'm going to go out to the hundredths place here. So 1.80277. So let's put 1.80. Okay, and that is our standard deviation. And this number, we'll talk more about this in detail later on. But the idea here is that the 1.80 number gives us a feel for how spread out this data is. Okay, so like, I'm not going to do this right now. Maybe I probably should, but what if our data points were more like, 1, 2, 2, 3, and then, what if we had like 14, 15, and let's see, 1, 2, 2, 5, 8, 22, 37, and 19. Okay, so the funny thing is that the mean of our first data set is 8. Okay, the mean of this data set, if you actually added them all up, so if you do 1 plus 2 plus 2 plus 3 plus 14 plus 15 plus 19, you get 56, and if you divide by 7, you will also get a mean for this data set of 8. But clearly, this data set here that I just made up is way more spread out from the mean than this data set is. So you should expect, and you guys should probably try this right now on your own, since you're Metro students, and I know you have plenty of free time. You should try and see what the standard deviation is for this, because I can guarantee you it's going to be a lot bigger than the 1.80 that we got down here. Okay, so we'll work with this more later, but that is the idea, and that's how you calculate standard deviation.